So this is the third video, picking up on number 17, right where we left off. We need to graph this exponential function, y equals 3 to the x power minus 4. So this is time consuming. The steps I told you to take were to ignore the k value. So you box in the y equals 3 to the x. That way, when you make an xy table, you could just focus in and use that y equals 3 to the x. We're going to ignore k for a while. So right here, we rewrote y equals 3 to the x. We made an xy table. We're going to use consecutive integer inputs. It doesn't mean we're going to have or use all those coordinates, but we're at least going to set it up that way so we could get a good understanding of how this is growing. So once again, the easiest input would be 0. Let's plug in 0 right there to the parent graph. 3 to the 0 is 1. So our output is 1 when we plug in 0. Now from that point, technical difficulties. Okay, so I plugged in 0, I got out of 1. Now from this point, I am just going to make it grow with the growth factor, which is the base 3. So if I take the 1 and then multiply it by 3, I will get my next output 3. And then if I take that 3 and multiply it by 3, I'm going to get the next output 9. And if I multiply 9 by 3, it's 27. That's already off the graph. As a matter of fact, 2, 9 is already off the graph. So I'm not even going to worry about 2, 9. Going in the opposite direction, if I'm multiplying by 3 going this way, going backwards would be dividing by 3. So this one would be 1/3. Or you could think of it as multiplying by 1/3. And then the next one would be 1/9, and the next one would be 1/27. And we already know that it gets smaller and smaller closer to 0. So let's graph the coordinate 0, 1. 0, 1 is right here. Let's graph the coordinate 1, 3. It's right there. And if you went to the coordinate 2, 9, you would be off the graph, like way off the graph. So I'm not even going to bother with that. But I am going to go to -1 and 1/3. So what does that mean? At the origin, I go -1 on the x, and then 1/3 of the way up. It's not even halfway up. It's about right there. Okay. So let me put the dot at -1 and 1/3. It's not even halfway up. And then the next one, -2 and 1/9. So if we go -2 and 1/9, it's hardly anything. It actually looks like it's probably touching. And we know it gets closer and closer. Now, keep in mind that these coordinates are from your parent graph. You still need to take into consideration the k-shift, and the k-shift is -4. Now, you could technically subtract 4 from your y values. That way you don't have to do these parent graph coordinates. But I like to draw the parent graph and then move them all 4 units down. So this guy up here is going to go down 1, 2, 3, 4 right there. And then the next one's going to go down 1, 2, 3, 4 right there. And the next coordinate that's at the -1 and 1/3 of the way up, that's going to go down 4 units, but it's at the 1/3. So think about it, right here, right here, right here, and right there. So our asymptote, which used to be up here at the y equals 0, is now at the y equals -4. So that's where your graph has to end up, and that's how we know that this is the graph. You just connect it all to the asymptote, and then put an arrow going up this way, and that's it, you're done. Now, in addition to that, now mind you, this is going to be multiple choice. There's going to be several graphs. So just by knowing that your base produces a growth, just by knowing that, you know that from left to right it's going to go up, just by knowing your k value of -4, you're going to be able to see all the 4 different graphs, and you'll be able to eliminate some of them because some of them are not at the k value of -4. So the multiple choice is going to be a lot easier than you actually graphing from scratch the way we did right here. And in addition to graphing, you also need to state the domain and range. And we should all know that the domain is x equals all real numbers. X equals all real numbers. And the range, that's the interesting one. That's where you have y. It's either above or below your k value. And of course, the k value is right here at -4. And this whole blue graph is above the value of -4. So that'd be greater than -4. And it is important to know your domain and range because on some of the multiple choice answers on the midterm, they actually give you the same graph, which are both correct, but then you have to read domain and range and identify which one's the correct domain and range. So you'll be able to determine the correct answer, but by knowing everything. Let's move on to number 18. And same thing, we're going to graph. This one's a decay function. Let's graph the decay function. We're going to, again, ignore the k value. We're going to just focus in on the parent graph. Ignore the k value. We're going to do a quick xy table. We're going to use consecutive integer inputs. Let's plug in the easiest one, 0. And if you do plug in a 0 right there, 1/3 to the 0 power is 1. Now from there, I'm going to take that output 1 and I'm going to make it decay by the decay factor of 1/3. In other words, I'm going to take the 1 and then I'm going to multiply it by 1/3, and that'll give me my next output. So that will be 1/3. And then if I take that 1/3 and I multiply it by 1/3 again, I'll get my next output, which is 1/9. And then multiply it by 1/3, 1/27. Now we already know that 1/9, it's hardly anything, so it's super close to nothing. But that's the pattern that we have, multiplying by 1/3, multiplying by 1/3, all the way down. Going backwards, it would be multiplying by 3. So if we multiply by 3, we'll get 3, 9, and 27. So of course, we're only going to use, well, this is a 10 by 10 graph, so we could use all these guys. Let's start with the 0, 1. 0, 1 is right here. Let's go to -2 and 9. It's right there. Let's go to negative, whoops, I'm sorry. I skipped -1 and 3. -1 and 3 is right there. -2 and 9 is right there. 1 and 1/3. So if you're at the origin and you go 1 and then 1/3 of the way up, it's not even halfway up. Let's put a dot right there. And we already know that it gets closer and closer, infinitely closer to 0. So you're just going to draw some dots like if it's actually touching the x-axis, even though we know it never actually touches, it just infinitely approaches. So that's the parent graph coordinates. We still need to take into consideration the k value, the -6. So I need to shift every single one of these coordinates 6 units down. So this dot's going to go 1, 2, 3, 4, 5, 6 right here. This next one's going to go down 1, 2, 3, 4, 5, 6 right there. And the next one, 6 units down, 1, 2, 3, 4, 5, 6 right here. And it's always good to shift your original asymptote, which was at y = 0, 6 units down. So you will end up right here, 6 units down. And all you have to do now is connect those blue dots and just approach your asymptote. And there's your graph. Now, in addition to that, the domain, x equals all real numbers. The range, you're going to put y is what for the range? Is it above or below your asymptote value? Is that blue graph above or below this green line? It's above, right? So y is what? Above, greater than -6, the k value. Okie dokie. So let's look at number 19. It says determine if the sequence is arithmetic, geometric, or neither. Explain why. Remember, arithmetic has a common difference. Geometric has a common ratio. Okay? So, and the way to find out whether it's arithmetic or geometric, you have to pick a number and then either subtract the previous number from it or divide it by the previous number. So if I did take 4, let me do it in red, 4 divided by 20, 4 divided by 20, I'm going to test and see if it's a common ratio. What is 4 over 20 reduced down to? If you reduce by 4, 1/5, right? So maybe the common ratio is 1/5, but we need to check all of them. So if I go 20 over 100, let me do that. 20 over 100. The zeros do cancel, and 2 over 10 does reduce down to 1/5 as well. Now let's try this other one. Let's try 100 over 500. That's definitely 1/5 because the zeros cancel and you're left with 1 on top, 5 on the bottom. So it's absolutely geometric, right? Geometric. And the reason why, it says explain why, because it has a common ratio r equals 1/5. Let's move on to number 20. Right here on number 20, they're not asking if it's arithmetic or geometric. They're telling you it's geometric, and they want you to find the next three numbers. So if they tell you it's geometric, you know it's a common ratio, and you don't have to make sure that it's common. You already know it's common because they told you it's geometric. So let's just take the 6 and put it over 36. So what is the common ratio?
6.
Close. 1/6. So the common ratio is 1/6. Now, you could use the common ratio and your a sub 1 term to write the rule to be able to produce the next three numbers. But if you understand what the common ratio actually does, it produces the next number. So if you took your calculator and you said 1,296 times the fraction 1/6, it'll give you 216. If you take this and multiply by 1/6, it'll give you 36. If you take 36 and multiply it by 1/6, it'll give you 6. If I take 6 and multiply by 1/6, that'll give us my next number. What is the next number? What is 6 times 1/6? That's just 1. Think about it, guys. 6 times 1/6. Oh, the 6's cancel. Your answer is 1. Or if you didn't cancel them, it would be 6 over 6, which is 1. So if I do have the next number being 1, what would the next number after that be if I need to multiply it by 1/6 again? It'll give you 1/6. And how about the next number? 1 over 36. And those are the next three numbers. We're done. Now, number 21A, that's more fun, because right there they actually want you to write the equation for the nth term of the geometric sequence 32, 48, 72. Okay, so we first need to have the a sub nth term memorized. A sub n equals a sub 1, that's just your first term, times the common ratio r to the power of n minus 1. So we know that the a sub 1 term is simply 32, and the common ratio we could find by simply picking a number and putting it over the previous number. So if I pick 48 and putting it over 32, that will give me the common ratio, but let's reduce. And what could we reduce by? So this does reduce down to 3 over 2. So this is your common ratio, r, 3 over 2. So we're going to create the rule. We're going to write the equation. So here's the equation. A sub n equals a sub 1, which is 32, times the common ratio, which we found out was 3 over 2, to the n minus 1 power. So this is one part of your answer. Now after that, they want you to find the sixth term. So what they're really looking for is a sub 6. Now remember, a sub 6, that's just the name or the notation stating that I'm going to take this equation and I'm going to plug in a 6 right there. So let me rewrite this thing. 32 equals 32 parenthesis 3 over 2, but instead of n minus 1, I'm going to put 6 minus 1. So a sub 6 is simply plugging in 6. So on the calculator, we're going to type in 32 times 3 over 2 to the power of 5. And on the calculator, your final answer is 243. So there's a couple more sections left. We have some radicals. And we have more systems. I want to save this till the next video.